Hello everyone, hope you guys are doing well. On this video I'll be talking about the solution for the test 2 that we had recently. So the first question is recognizing the type of cells we have. As you can see in the one on the right, we have two containers. This is the one for voltaic cell, and the other one is electrolytic cell with one container. Okay, I will go more into details of those in the next questions. The other difference with the voltaic cell is that it has a salt bridge, while the electrolytic cell doesn't have a salt bridge. We can also call voltaic cell galvanic cell. Okay, galvanic cell. Just gonna rewrite this. Okay. Now we move on to the second question. Oxidation is loss of electrons and gain of oxygen or loss of hydrogen. We have covered this. Oxidation is loss of electrons, gain of oxygen or loss of hydrogen, so which is why this is true. The third question, in which the species does manganese exhibit the highest oxidation number? So I'm just going to work it together with you guys. So manganese in the first one is by itself, so it's going to be oxidation state is going to be 0. And then we have manganese oxide. I told you guys that oxygen is always -2, and this whole thing adds up to 0. So if even we're going to say this is x, so we're going to say x. So because there's 1 of manganese, 1 times x plus 2 times -2, which is the oxidation number of oxygen. It adds up to 0 because this whole thing is 0. And then we say x minus 4 is 0, x equals 2 plus 4. So in this case, manganese is plus 4. The first one is 0. Let's check out the D, which is manganese chloride. So everything adds up to 0 again because there's no charge given on the right corner. And we know that halogens, fluoride, chloride, bromide, and iodine, they are always -1. I have discussed it in the other videos. You should check them out. So this is -1. There's again 1 of manganese, and we don't know the charge. So 1 times x plus 2 times -1, 2 here, it adds up to 0. X minus 2 is 0, x is plus 2. So it is plus 2 on this one. And let's check out this guy, cadmium manganese. Okay, and then over here we know that it adds up to 0. The first group element, potassium, lithium, natrium, they're all +1. So this guy is +1, this guy is x. We know that oxygen is always -2 charge. So let's do the math. So 1 of potassium, which is 1. Sorry. So 1 of potassium, 1 of manganese. 1 times +1 plus 1 times x plus 4 times -2, which is 0. And then 1 plus x minus 8 is 0. And then x minus 7 is 0. X is plus 7. So because this guy is plus 7, this is going to be our choice. Okay, now we'll move on to the fourth question. On this one we had, what's the reduction of equation in the following redox reaction? So I'm going to show you guys how to get the half reactions on this one. I know that a lot of you asked. So here we go. So first thing you do is that you write down oxidation numbers. I told you guys when the element is by itself, you see like it comes in 2, but there's no other element than hydrogen. So that's why it's going to be 0. Chlorine is by itself, so it's going to be 0. It doesn't matter whether it has 2 of those or whether it is sulfur that comes in 4 or sulfur comes in 8. They're all zeros, okay? Or you could say bromine, again, which is comes in 2. Again, it is 0 charge. So, and over here, I told you that fluorine, chlorine, bromine, and iodine, they are halogens, and they are all -1 charge. So this guy is negative when it combines with someone else, but by themselves they are 0, as I pointed in here. Okay, so hydrogen in this case, because it needs to add up to 0, hydrogen becomes +1. Okay, so now let me delete this side over here. You need to take a note so as you go through this video. So hydrogen went from 0 to +1. Chlorine went from 0 to -1. Okay, so some of you are really struggling to know whether there is oxidation or reduction. Okay, let's write this hydrogen on this side. Okay, I don't need any of this number 2's. Don't worry about them, or any coefficients that is in front of them. I only need element hydrogen with 0, and on the left side, as you guys can see, and on the right side we're gonna also talk again about the hydrogen. We're trying to write the half reactions. Okay, half reaction. This is the reaction is given here is overall reaction. Now using this I can get 2 half reaction. One is going to be oxidation, the other one is going to be reduction. So as you guys can see, hydrogen went from 0 to +1. So just a simple idea from math. When the number goes from lower value to higher value, in this case which is 0 to 1, okay? So if we put the 0 in here and the coordinate system like this, okay, if my number goes higher, doesn't matter from any point, it is oxidation. Okay, if it goes lower, it is reduction. Simple as that. So let's look at here. So our number went from 0 to +1. So that's why this reaction is oxidation half reaction. Okay, and in order to balance this, I'm just gonna look at the charges. So what do I have? I have a 0 charge in here, and I have a plus charge on the left side. As in chemical equation, it is a mathematical equation as well. We need to balance the charges. So we need to make both sides equal. Currently it's not equal, it's 0 and +1. The only chance I have is to add electrons. As we know, one electron carries -1 charge. So if I add -1 in here, they both become equal, right? That means that I need to add electron on the right side. If I add electron on the right side, they both balance. Okay, so it is clear that it got balanced. But as you can see, this is my reactant side, right? Reactant side, and then this side is my products. So what happened here? I lost 1 electron as a product. So that's why we said that oxidation is loss of electron. But let's now look at here to chlorine. Okay, chlorine is on the left side and on the right side, went from 0 to -1. Because chlorine went, as you can see, the number in here went from 0 to -1. So what happened if you look at here? It went downwards, right? Downwards. That's why it is reduction. Okay? So this guy reduced. I'm cleaning stuff up. So it went from 0 to -1. So let's now do the charge balance. So I have 0 on this side and I have -1 on this side. I need to make both sides equal, and the only option I have in here is to add electrons. As I said, electrons are, 1 electron is -1. So if I add -1 in here, this is going to become equal, right? That means that I need to add 1 electron to left side. Now it's balanced, as you guys can see. So what happened here on the reactant side? On my reactant side, I added electron, which means that I gained electron, but I lost over here, right? So that's why we said that oil rig, which is oxidation, is losing electrons, reduction is gaining electrons, right? So I gained electron on the left side, I lost electron on the right side as a product. So that's why this is reduction half reaction. So as you guys can see, I derived two equations. So let me write them clearly for you. So oxidation half reaction is hydrogen going on this side, 0, and then plus 1, add 1 electron, and reduction is chlorine 0 plus 1 electron is chlorine minus. Okay, these are two half reactions. So now it's asking what's the reduction half equation. Okay, so we know that this is the guy, so we're choosing this one. Answer is B. Okay, now we go into the next question. Choose the correct options. Memory 1. It's a 1-point question. Oxidation state of oxygen in hydrogen peroxide H2O2 is -1. So we know that this is an exception. I can show you how. So H2O2. Hydrogen is a first group element, so it is always +1, right? We know that it adds up to 0. If we do this one here, so 2 times +1 plus 2 times x, it adds up to 0, and then 2x is -2, x is -1. This is only exception we have for oxygen, is that when we have peroxide like this, it is -1. If you can check my oxidation manual, you will see it over there. The sum of oxidation states of HNO3 is 0. We have done it many times, and you know that when I do my math, I sum up to 0 because there's nothing is given on the top right corner. If there's no charge, that means that it is 0. So on this one, oxidation state of SO4 -2 is 0. As you guys can see, it is given that it is -2, so it's clearly not the right answer. So 1 and 3 are not the right answer, and this is 2. And then we go aluminium, which is the member of third group element, has an oxidation state of +3. So the first group elements are +1, second group elements are +2, and the third group elements are +3. So that's why the question, this one 4 is right in here as well. Okay, so now we go into here. It's asking what's the oxidation state to each component, element, and ion shown below. Okay, let's do it together. So H2SO4, I will write it in here. So we know that oxygen is -2, hydrogen is +1, they add up to 0. If I do the math, 2 times 1 plus, I say sulfur is x, plus 4 times -2 adds up to 0, and then x plus 2 minus 8 is 0, x minus 6 is 0, x is +6. So this guy is +6, that's why it is C. And then this one in here, they add up to 0. We know that oxygen is -2, this gotta be +2. This is why this is A in here. Iron in chlor 3. So this one in here, we know that chlorine is always -1, and this one is x. It adds up to 0. Let's do the math. So 1 times x plus 3 times -1 is 0. X minus 3 is 0. X is +3. So this one is +3. So this is going to be D. And then CO2, it's asking for oxygen. We know that oxygen is going to be -2. So this one is -2, and this is B. The only exception we have oxygen is H2O2. sodium 2O2 over here, it is -1. Other than that, it is always always -2, which is B. Okay, so now we go into the next question. Below are statements about voltaic and electrolytic cell. Identify statement that are correct for electrolytic cell but not for voltaic cell. Okay, as you guys have seen over here, they both have electrolyte solutions. So the first one, electrolyte is needed in the cell. It says that it gotta be true for electrolytic but not for voltaic. So this is not the answer. Cathode is negative electrode. A spontaneous reaction occurs. Salt bridge is not needed. We know that electrolytic cells are always non-spontaneous, so this one is incorrect too. Salt bridge is not needed, where we know that electrolytic cells are going without the salt bridge. I showed you guys in the first picture, so there is no salt bridge in here, but we have for voltaic cell. So the salt bridge is not needed is the answer. And then we know that for voltaic, anode, where the oxidation happens, is negative, and cathode is positive. And for electrolytic cell, anode is positive and cathode is negative. So cathode is negative, that is right, but for voltaic it is positive, so that's why that's the answer. It's 2 and 4. Now we move on to the next one. In the following reaction over here, determine and justify what is oxidized, what is reduced. So before we go, we need to find the oxidation numbers. So we know that by itself chlorine is going to be 0. But when you make a compound, all the halogens, fluorine, chlorine, bromine, and iodine, they are -1. And over here it is -1. And the whole thing needs to add up to 0, right? So if we do the math, and this one is x, so x plus 2 times -1 is 0, so x becomes +2. So this guy is +2 here. And if you do the math on this one, this is going to be +3. Okay, I'll show you guys how I do this one too. So in here I have this whole thing adds up to 0. This is -1 and this is x. So because there's only one of them, I do the math. 1 times x plus 3 times -1 adds up to 0. And then x minus 3 is 0, x is +3. So that's why this guy is +3. Okay. +3. So if we do in here, we know that iron went from +3 to +2 to +3. Okay, so if we do the charge balance, this is +2 in here and this is +3 in here. We need to make them equal. The only chance we have is to add electrons. If I add one -1 in here, which means one electron, they add up, right? They become equal. So that's why, because I lost electron, also my number went from smaller number to higher number, from 2 to 3. This is oxidation, okay? And then if you look at the chlorine over here went from 0 to -1. Don't worry about this chlorine. Worry about the sign change. Whichever there's a sign change, then include that one on the left and include this one that we have on the right. So now we do charge balance. There is 0 in here and there is -1 in here. How can we make them equal? If I add one -1 in here, and then they become equal, which means I need to add electron to left side. So as you guys can see, my number went from higher number to lower number. I also, the other terms is like gaining electron. I gained electron on this side, on the left side, and I lost electron on this side as a product. So that's why this is reduction and this is oxidation, half reaction. I will write them clearly here. So the first one, oxidation is iron plus 2 goes in here. This is oxidation, and the reduction is chlorine 0 plus electron went to chlorine negative 1. That's it. That's all for the half reaction. Now it says determine just why oxidized and what's reduced. We say that iron is oxidized, and then chlorine is reduced. Okay, and now it's asking oxidizing reducing agent. We know that whatever is oxidized is reducing agent because it is given out electron, and then chlorine is oxidizing agent. Okay, now we go into the next question. Over here it's saying use the oxidation numbers to determine which elements are oxidized and which are reduced. Let's do this together. You need to write down, some of you have written in terms of oxygen loss and hydrogen gaining, but over here I'm asking using oxidation numbers. So let's go to it. We have in here sodium. By itself, any element is 0 unless there's no charges given. So hydrochloric acid. I said that all the halogens are -1. They need to add up to 0, so this guy is going to be +1. And then chlorine again is -1, and sodium is first group element when it binds with someone else, so it's going to be +1. As also we know that they need to add up to 0. +1 plus -1 adds up to 0. Hydrogen by itself is going to be 0. If you want to review this, check out my oxidation manual video. Everything will be clear for you over there. So sodium, we need to look at the number change. Okay, sodium went from 0 to +1. You see my number increase from 0 to +1. So this is gotta be oxidation. So sodium went from 0 to +1. And then in order to balance this, we know that 0 is here, add +1 in here. If I add -1 on this side, this is going to be equal. So this -1 is 1 electron. And we know that electron is lost as a product. Also our number went from 0 to +1 to higher number. That's why it is oxidation. Okay. So sodium oxidized, sodium is oxidized. Okay, now let's write the half reaction of reduction. Look at the number where the number went from higher number to lower number. As you guys can see, hydrogen went from higher number to lower number. So if I write down in here hydrogen +1 went to hydrogen 0. Okay, so in order to balance this, let's do the charge balance. I write +1 in here, I have 0 here. If I add -1 on this side, both sides will be equal, right? So this -1 is just 1 electron, and 1 electron is gained, right? And also because my number went from higher number to lower number, I know this is reduction. So hydrogen is reduced. Okay, now we go down. So as you guys can see, we can say that using the oxygen, CO2 lost 1 oxygen, made CO, we know that it reduced. But now I'm asking regarding the oxygen number went from 2 to 1. It is reduction. But now let's write it using the oxidation numbers. So hydrogen by itself is 0. Okay, we know that. Oxygen, when it binds with someone else, except the peroxides, it is always -2. Now it needs to add up to 0. We know that if we do the math together, it becomes x on this guy, 1 times x plus 2 times -2. It adds up to 0. So x minus 4 is 0, x is plus 4. Okay, x is plus 4, so in here we have carbon plus 4. If you do the math, this is negative 2, it needs to add up to 0. This is going to be plus 2, and oxygen is negative 2, hydrogen is a first group element, and they need to add up to 0, so this will be 1. If you do the math, 2 times plus 1 plus 1 time negative 2, they add up to 0. Negative plus 2 minus 2 is 0. Okay, so now let's look at the numbers. Carbon went from 4,2 to 4,4,2,2. So the number of the carbon oxidation number went down, right? From 4 to 2, number decreased. So this is reduction. And if we do a charge balance, I have plus 4 in here, plus 2 on this side. If I add negative 2, which means I need to add 2 electrons on this side, they become equal. I gained electron. Also, my number went from 4 to plus 2. That's why this is reduction. So carbon reduced, or we could just say CO2, where the carbon is located, CO2 is reduced. Okay. Now we'll look at hydrogen. Hydrogen went from 0, 0, 2, as you guys can see, 2 plus 1. Hydrogen went from 0 to plus 1. So its number mathematically increased from 0 to plus 1. Also, if you do charge balance, this is 0 and then plus 1. And here, if I add one negative 1 on this side, they become equal. That negative 1 is 1 electron. As you guys can see, I lost electron as a product. And that's why it is oxidation. And we say H2 is oxidized. Okay, our next question is the question number 10. And on this one, we're going to complete the half reactions. It's a super easy question. Most of you answered this one right. So I'm just going to re-clarify this. So as you guys can see, we have zinc with a 0 charge going to zinc to plus 2 charge. So because mathematically my number increased from 0 to plus 2, I know that this is oxidation. Okay, and one more thing is we need to add electron to balance this reaction. So we're going to do oxidation state balance. So we know that on the left side we have a 0 charge. On the right side we have plus 2. And we need to make this equal as a mathematical equation. The only way to do it is by adding electrons. And one electron is negative 1. So I add on this side negative 2, which makes this oxidation state number balanced. So that means that adding 2 electrons. And this was the final ending that was required from you. And the next one, I'm going to quickly do this one on here, copper plus 2, go into copper. So on this one, because it went from 2 to 0, the number dropped. We know that it is reduction. And in order to balance this, you make this side plus 2. We do oxidation state number analysis. And 0 on the left side. The only way to balance this if we add 2 electrons in here, which means adding negative 2. So negative 2 on the left side will make both sides equal. And then I would add, that means adding 2 electrons. Okay. So another way of looking at it, as I talked before, as you see in the first one, as a product side, I lost electron. On the product side, if you see electrons on the right side, that means I lost electrons. Okay, that's why it is oxidation. That's another way of looking at it. And on the bottom one, because I gained electron on the left side, this is gaining. To make the product, the reaction that happened is reduction. Okay, now we move on to the next question. I think I really went deep on this with the other question above. So consider the following question: deduce the oxidation states of hydrogen, chloride, in reactants and products. So we know that element by itself is 0 and 0. So I'm just gonna write this like this. And then on the next one, we have hydrogen chloride. So we know that we don't care about the coefficients in front of it when we do oxidation number uh, calculation. So we know that -1 is for chlorine because they are halogens, and as this thing is adding up to 0, the hydrogen is going to be +1. And we also know from the oxidation manual that hydrogen is +1 most of the time, 95%. Okay, that was for the first part. Now we go into the second state: which element oxidized and which element reduced. So we see from here that hydrogen went from 0 to 1. So we always look for change. If there is no change, we don't even bother to write them down. So hydrogen in here went from 0 to +1. Notice that I didn't even use coefficients. I just wrote elements. That's what's required from 2-hour class. So because my number changed from 0 to +1, like it increased, I know that it is oxidation. Okay, so that's why I know that hydrogen oxidized. But let's complete the half reaction. So currently I'm writing half reaction of oxidation. So hydrogen goes from 0 to +1. I do a charge balance to finish this. So +1 on the right side. I need to make this equal both sides. So I need to add -1 on this right side. As you know, I only can add electron. Add electrons. Each electron carries -1 charge. So that means that adding 1 electron in here, and now both sides are equal. So this is oxidation. Hydrogen is oxidized. And then we look at another change. Chlorine went from 0 to -1. So the number mathematically dropped down. Okay, -1, we do a charge balance. We know because mathematically number went down, it is reduction. So we say chlorine is reduced. Now let's complete the half reaction. We do charge balance 0, -1. In order to make to both sides equal, we need to add -1 on this side, which will make both sides equal, and that means adding 1 electron. Now the half reactions are complete. And now it's asking identify oxidizing and reducing agent. So we know that hydrogen is oxidized, so hydrogen is reducing agent, and chlorine is oxidizing agent. I think most of you answered this right, so I'm not going to go into too much detail. For question 12, we're looking at electrolytic cell. So this is one of the problematic questions, so I'm just going to go into detail on this. So as soon as you start with this one, you need to do charge balances. But let's read the first part. In the electrolytic cell, above anode is positive electrode, and electrons move towards anode. Notice this, electrons never move towards anode. They move towards cathode. Because anode donates or loses electrons. As you know from Anox Red Cat, because oxidation happens at anode, we lose electrons at anode. Okay, we're not gaining them, but this statement suggests that we're gaining electrons at anode. Okay, that's why this is false. But the other stuff, electrolytic cell above is in anode is positive electrode. I will show you why it is correct. And the red cat, we know reduction. reduction happens. In cathode, okay, and we know that cathode is gaining electron, anode is losing electrons. Okay, so and one more thing about the charges. So for voltaic cell, there is one thing you need to memorize. Voltaic cell, anode is negative, cathode is positive. For electrolytic cell, anode is positive, cathode is negative. I will explain this charges again, but it will help you out once you memorize, because I know that some of you did and they got the correct answer. Okay, so explain now the second part. Explain why this reaction occurs only in electrolytic cell but not in voltaic. The reason is that in electrolytic cell, the reactions that are non-spontaneous will happen. All you need to say is non-spontaneous reaction. Some of you did. So non-spontaneous reaction, that's why this reaction only happens in electrolytic cell. Like this salt, it's a chemical salt. It does not dissolve into two, decompose into two by itself. We need to put electricity through battery, so this reaction will happen. Now it's asking write the half reaction that happens in cathode. Okay, so before we go into half reaction, we need to do charge balance. Okay, so we know that elements by themselves, they're zero. Chlorine, because it's halogen, it's always -1. And this thing needs to add up to 0. So we put X on zinc, so we have only 1 of zinc. Let's do the math. So 1 times X plus 2 times -1 is 0. X minus 2 is 0. X is plus 2. So zinc in here is plus 2. So what happened to zinc? Zinc went from plus 2 to 0, and chlorine went from -1 to 0. We're looking for a change, and we see them. So let's write the element by element to write the half reaction. But before we move, I want you to, like, now we're looking for cathode, right? Cathode is the one where the number of the oxidation number drops. Okay, cathode, because that's where the reduction happens, right? We know that cathode, red cat. Cathode is where reduction happens, okay? Reduction happens, so the number mathematically drops. As you guys can see, it went from +2 to 0, so it mathematically dropped. So right away we capture zinc in here. We say, okay, zinc +2 went to zinc 0, and this is reduction because we're looking for cathode. Okay, and then reduction reaction, and we do charge balance to finish this half reaction. So +2 on the left side, 0 on the right side. How can we make this balanced? If we add -2. Okay, now this will be balanced, and -2 means 2 electrons because each electron is -1. Okay, the cathode is done, and the next one is the chlorine. As you guys can see, chlorine goes from -1 to 0. So it mathematically went up, okay, from -1 to 0. The number goes up. So we know that this is oxidation. The other way of knowing it's oxidation is using electrons. So let's do the charge balance before we finish this reaction. -1 and 0 on both sides. On the right side 0. We need to add -1 on the right to make this reaction balanced. And this means adding electron on the right side. Okay, now this is balanced. We have written our oxidation. Another way of looking at this is we see if we lost or gained electron. As you guys can see, on the reactant side, I gained electron. You see, on the reactant, I gained electron. That's why this is reduction. And this is why it happens in cathode, because of the red cat. And then on this side, I lost electron at the product, lost electron, which means it is oxidation, and oxidation happens at anode, anox, red cat. Okay, so we're done with the question 12. Now let's do the question 13. And in 13, I'm gonna do the following is an equation for redox reaction. Define oxidation in terms of electrons. So oxidation is loss of electrons. We talked about this many times. Is loss of electron. Okay. To use the oxidation state of carbon and CO2, oxidation of, now it's asking carbon in C and carbon in CO2. Because C is just carbon itself, we know that carbon is 0. So, and then it's asking for CO2. Let's do the charge balance. So CO2, we know that oxygen is -2 and C is X. And there's only one of this. Okay, let's do the math together. So 1 times X plus 2 times -2 is 0. Because there's nothing given on the chart, so we add up to 0. X minus 4 is 0, X is plus 4. So in carbon dioxide, in CO2, carbon charge is plus 4. Okay, and carbon in C is going to be, carbon in C is going to be 0. Because element by itself is 0, as I written in here. So plus 4 on this guy. And then it's asking for sulfur in SO2 and H2SO4. So SO2, let's start with this one. It is much easier. So SO2, because we know that oxygen is -2, sulfur is X, they're adding up to 0. Let's do the math. So there's only one sulfur, that's why it's not written. So 1 times X plus 2 times -2, they add up to 0. X minus 4 is 0. X is plus 4. So sulfur in SO2 is plus 4. Let's do H2SO4. Where is the space? So H2SO4. So we know that oxygen is -2, hydrogen is plus 1. So plus 1, -2, and sulfur is X. Let's do the math together. They add up to 0. So 2 times 1 plus, there's only 1 of sulfur, 1 times X plus 4 times -2 adds up to 0. And then 2 plus X minus 8 is 0. X minus 6 is 0. X is plus 6. So sulfur in H2SO4 is plus 6. Okay, now it's asking identify products formed by oxidation in this reaction. So before we go, we need to know that the numbers mathematically need to go up in oxidation for us to call this oxidation. So sulfur went from plus 6 to plus 4. So it mathematically dropped, right? Went down from 6 to 4. So this is reduction. Okay, but in carbon, it went from 0 to plus 4. The number increased, right? From 0, it went to plus 4. So it increased, that's why this is oxidation. And the product of oxidation is CO2. So you guys needed to write CO2 in here. Some of you did, some of you didn't, but next time just use this. Find where oxidation happened and choose that product. Okay, now the next question is voltaic cell. It's 14. So this is a question that it was a little problematic in here too. But now let's go at it. So I said that in voltaic cell, anode is negative, cathode is positive. And we know from Anox red cat that oxidation happens at anode and reduction happens at cathode. Okay, so it's asking determine which electrode is positive. So you guys are familiar with this. I have zinc on the left side and I have copper on the right side. I know that when it's asking for positive electrode, I am looking for cathode, right? So I'm looking for cathode, but I need to figure out which of these elements are going to be cathode, like where the reduction happens, right? So writing just cathode is not enough for me. You need to tell me which of these electrode, copper or zinc, is cathode. So because I know from activity series zinc is sitting higher than copper, I know that zinc will oxidize, and copper will reduce. Okay, that is why the cathode, where the reduction happens, is the copper electrode. Okay, that's the answer. Write the equation for the reaction at the positive electrode. So we're looking at the positive electrode. Positive electrode is the cathode, and we know that this is copper. So we know that copper has a +2 charge, and positive electrode means that the reduction happens. The copper inside this is reduces and sticks to the wall of this electrode. Okay, it sticks to the wall. Copper +2 that is dissolved inside the solution. So reduction reaction is copper +2 goes to copper. As you see, copper is 0 here. My number mathematically went from 0 to +2 to 0. So from +2 to 0, so my number decreased or dropped down. That's why this is reduction reaction, and reduction happens at cathode. Okay, now I need to finish this half reaction. Write the equation like it's literally asking for copper half reaction. So on this one here, I need to do charge balance. So +2 in here, 0 in here. In order to make this balanced, I need to add -2 on the left side. Now this is balanced, and this means adding 2 electrons to the left. Okay, so now it's balanced, but there's one more thing. It's asking state symbols. So you guys see that copper +2 is an aqueous solution, while the copper is 0 charge is solid metal. Okay, so we need to write in here aqueous solution and solid in here. Now we're complete. And now on the third question, explain the role of salt bridge. So this one, salt bridge, was balancing ions. As you know, there was a charge buildup, balancing ions to complete circuit, complete electric circuit to ensure electron flow. So you don't need to exactly write this, but your explanation need to kind of go along this line to say that, because the salt bridge, where, as you know, all the copper +2 goes and sticks to the wall. Now we have a negative charge buildup in here and positive charge buildup in here, because lots of zinc +2 are coming in. This guy is eroding, so there's a lot of +2 charge in here. So salt bridge sends over here negative charged ion and positive charged ion on this side, and it neutralizes and balances the reaction. So balancing ions, or you could say neutralizing They're all valid statements. Okay, identify a suitable compound that may be used in salt bridge. You can use sodium chloride, as it says from the name. It's gotta be salt. So sodium chloride is a table salt, the one you know the most. But there are salts like sodium nitrate too. Okay, there are salts like sodium sulfate too. These are all valid salts. You can just write one of them and it will work. Okay, so we're now in question 15. On this question, we're going to be talking about the activity series. We're going to figure out which elements are more active, more reactive than the other. So you guys know that when the reaction happens, that means that it is spontaneous. Okay, so this reaction we see that is spontaneous reaction. It's single replacement or displacement, whatever you want to call it. Okay, so over here, if we want to find the charges, we know that x by itself is going to be 0. Okay, and then y, because chlorine is -1, this whole thing is going to add up to 0. Y gotta be +2. We have done this calculation many times, so I'm not going to do it over here. So for this one, chlorine is -1, x is +2, and then y is 0. And then if I'll do for this one, again, it's -1, x +2. So we know that x, y, z, they all carry +2 charges. You do the same calculation, it's going to be by themselves, it's 0, 0, +2, and then +2 and 0. Okay, the other form we can write this is that I can write this reaction as x plus y to charge, and then x plus 2 charge plus y. Okay, this in here, because x kicked out, like, meaning you can't really write kicking out. I'm just giving you this kick out thing to explain you like in an easier way with the metaphor. But you need to say because x is more active, or because x is more active, and more activity means that easier to oxidize. This reaction happens. Okay, so the reaction is over here. You see that x went from 0 to +2. So x oxidized. Because it was easier for him to oxidize, he oxidized, while y got reduced. As you see, it went from +2 to 0. So it got reduced. But now if we check for this guy over here, we know now, using this data, we know that x is located higher on the activity series table. Okay, and then we look at the next one, y and x. Because y 0 plus x2 didn't happen, we know that y is located lower than x, as we found in here. Okay, otherwise, because if y would have been stronger than x, like more active, y would oxidize and x would reduce. But this reaction didn't happen because of the activity series. Okay, now we're looking at z. Z is kicking out in metaphorically, but what happens, because Z is more active, Z oxidizes, and then Y reduces. Let's check out with the sign. You see Z went from 0 to +2. Its number, oxidation state number, went from 0 to +2, so it increased. So that means that it got oxidized. And then Y2 went from +2 to 0, So it went downwards. We know that it is reduction, okay? And this explains us that x is, z is higher than y, okay? So we know that on activity series, z is higher than y. And then we check out this reaction in here, z and x. So z is reacting with x2. In here we see that z kicked it out. That means, in terms of chemistry, z got oxidized while x got reduced. You can see it from the numbers. Z went from 0 to +2, x went from +2 to 0. Because the oxidation number increased for Z, it got oxidized and X got reduced. That means that Z is located higher than X2. Okay, Z is located higher than X. So if we summarize all these three, we will know that Z is higher than X and Y. Okay. So in here, put the metals X, Y, Z in increasing order of activity. We put them like this, X, and then Z, and then Y, okay? And we say, explain our choice. We say that because Z is more active than X and Y, and we say X is more active than Y. Okay, you guys explained me using the kicking out and so on, like that was metaphor. You can't use the wording in the kicking out. Like if you go anywhere in the world, they're not going to accept that explanation. So I gave you guys some marks, but wasn't the full mark. Okay, so this is for the first one. Okay, this is, well, a lot of stuff, and it's very important for your midterm. You need to know this stuff. I'm going to summarize whole this reaction in one table, like once I'm done with the question 15. So in the second part, it's talking about completing sentences using reduced and oxidized. As you guys can see, because Z is more active than X, Z got oxidized in this reaction and this reaction. Because X is more active than Y, that's why X got oxidized. So we say that more reactive or more active metal is oxidized, and the less reactive metal got reduced. You could see that Z got oxidized and Y got reduced. Their oxidation numbers changed accordingly. Z went from 0 to +2, number increased, and then Y went from +2 to 0, it got decreased. Okay, and then using the activity series, choose two metals both for X and Y. So we know that X gotta be higher than Y. All you need to do, go to activity series table that is given above and choose two elements. We can choose lithium and, for example, silver. So lithium is gonna be X, and then silver is gonna be Y. So you needed to choose and show me what is X and Y. Some of you gave me just lithium and silver, and I don't know which one is going to be X and Y, so I didn't give a full point on that, just so you know. But in the midterm, please be careful with that. Explain, now the fourth question, explain which metal is stronger oxidizing agent. So oxidizing agent is got to be the one get reduced, right? So we know that X is less reactive than Z. That means that Z will oxidize, right? Oxidizing ones are always the reducing agents, okay? A better reducing agent. And the X, because it will get reduced, as you guys can see over here, on this reaction with X, right? Look at this reaction. Z got oxidized, and X got reduced. Okay, the one who gets reduced is an oxidizing agent. Okay, so that's why over here X is stronger, oxidizing agent, while Z is stronger reducing agent. Okay. Now, guys, before I go, I'm gonna summarize this in terms of table. Okay. So we got here X, Y, and Z metals, right? So let's write this in terms of a table. Let's make it right like here. X, Y, and Z. Okay. X, Y, and Z. So I got reaction. We know that X is higher than Y, Z is higher than X and Y. So I'm gonna do a chart like this, and then in the bottom I have so X plus 2, and then I will have Y plus 2 charge, and then I have Z plus 2 charge. Okay, so let's fill this table out together. So we know that metal with itself, so the way it goes is that this guy and this guy on this here, because they are the same metal, we don't worry about them. So we don't care about this reaction. And then Y with Y, we don't care about this. And then Z with Z metal, we don't care about their reaction with themselves. We care reaction with, for example, X and Y. Okay, so if we go into this reaction over here, we know that X is better at oxidation and Y is better at reduction, right? So because you see X and Y 2 plus charge reacted, we're gonna put that there is reaction. Okay, we put a tick mark or say reaction. Okay, and then we look at X and Z. So we know that, for example, this reaction over here is not gonna happen. So I'm just gonna write like that, like this, is that no reaction, because as you see, X gotta oxidize, right, and Z gotta reduce. So oxidize and reduce, and I know that Z is located higher than X, so this reaction is not gonna happen. So no reaction. But if we look at right now with Y, let's look at Z with Y2. So this reaction. So Z with Y2 plus. Now let's look at here. Before we go, actually, I'm just going to write this. So Z is higher than X and Y. We know that Z will oxidize while Y will reduce because Z is more reactive. We look at this reaction in here. As you guys can see, Z kicked out Y. Z got oxidized. It went from 0 to plus 2, and Y went from plus 2 to 0. So that's why in here I'm going to say for this reaction, because it happened, it goes like this: Z got oxidized, Y got reduced, oxidized, reduced. So I'm going to say that there is reaction. Okay, and then I do one more, Z with X2. The same idea, Z with X2. If you go above in here, we know that Z kicked out X, meaning that Z got oxidized while X got reduced because Z is more reactive than X. So this is the reaction: Zx plus 2, Z2 plus X. So there's reaction, and then we say that there is reaction here. Okay, and then let's look at the other ones. So X and then Y 0 and X plus 2. So Y 0 plus X plus 2. Okay, so I know that you guys see in here, because Y is less reactive than X, Y cannot kick out X. You see, like, it's over here. You see there is no reaction in here. Y with X plus 2. okay? Why with x plus 2 there's no reaction? So I'm just gonna say in here, I'm sorry. So in here I said, you see I put x in here. I meant like there's no reaction, not in terms of x. Okay, no reaction. So we go below. I know that there is no reaction, so I'm just gonna say on this one there's no reaction. Okay, now we have left only this guy. So y with z plus 2. So y with z plus 2. So let's look at here. I know that y is less reactive than z. So y cannot kick this guy out. Like this reaction, the one in here, for example, y plus 2 plus z0 is not going to happen. This is not going to happen because it's y is less reactive than z. But this reaction, z with y plus 2, will happen. Z will kick this guy out, Z will oxidize, and Y will reduce, as I have shown you above in here. Okay, so that's why this reaction, Y with Z plus 2, there's no reaction, and I'm gonna say, you guys can see this, so Y with Z plus 2, no reaction. Okay, so you gotta be able to, like, you make your own activity series and make your own table. Over here, as you guys see, we gave you unknown elements for us to know without even having activity series table to make your own stuff. So our stuff was, our stuff was z above, x in the middle, and then y below. Okay, this is y, x in the middle, and then z up here. Okay, this is your own activity series. As you go up, it's going more active, and then, sorry for the drawing. Anyways, you got the idea. So now I'm gonna give you one more important information for your meter. So we got here voltmeter. We talked about zinc and then copper. Okay, so let's write the reaction that happened in here. So we got in here. This is important stuff, guys. So do you guys remember the one we had in the lab? Don't worry, we're not asking you the questions that you had in the lab. No lab questions. But it will be helpful for me to use the lab experiment because you guys remember what we had as materials. Do you guys remember I had a zinc metal, a small zinc shiny metal, right? A shiny metal zinc, and I also had in the beaker, such a horrible drawing, I'm sorry. So in the beaker, I had a blue solution, and that was copper nitrate solution. Okay, so copper nitrate solution, it was like blue solution. You guys remember, like, it's hard to forget that. So what happened over there, I added zinc. So I took a test tube, I added a copper solution, copper nitrate solution, and then I added zinc metal into it. As you guys saw, a shiny metal went into dull colored, like it was like a reddish color metal. So I'm going to show you what happened over there. So if we write the reaction, zinc plus copper nitrate. Okay, so this guy was, if you guys remember, it was aqueous solution, right? And this was a solid metal. So copper nitrate, because we know that zinc is located higher in activity table than copper, I'm going to show you right here now. Maybe I should just go through here. So activity series, you guys see zinc is located higher than copper. So zinc will oxidize while copper So zinc will oxidize while copper will reduce. So, and or we could say like it kicked it out, like metaphorically. So zinc, I'm writing the reaction over here. Zinc kicked them out. Zinc became NO3 plus 2, and then copper. Okay, this is my reaction. If I write this in terms of just metals, as I did in question 15, let's find the charges of this guy. We know that nitrate ion is NO3 negative 1. We have done it many times. So negative 1, and then if I put x, I'll do calculation x plus 2 times negative 1 adds up to 0 because everything is 0 here, and then x equals 2 plus 2. So this guy is plus 2 charge. The same thing with here. Okay, now let's write this in terms of metals. So zinc plus copper, 2 charge. So this is solid, this is aqueous, and then we got here zinc plus 2 charge aqueous, because zinc is now in the salt form, and then we got copper. So do you see what happened here? Copper went solid. So that reddish metal, like we had zinc metal, right? So some of the copper started binding. It started like just literally absorbing onto floor of zinc. So it turned into reddish metal. Okay, maybe I should draw this using different colors. So it was zinc metal in the beginning, and then I had small, like a reddish copper sitting on this guy and covering it with a reddish color. And as you can see, the copper is solid now, and some of the zinc from the metal dissolved and went into the solution. That's why the color changed from blue into greenish color. It went into greenish. Okay, so now that we have this reaction, okay, let's write the half reactions. Do you guys remember? I said that I go from zinc 0 to zinc plus 2. I only look for changes. So zinc in here, I'm writing down half reactions. Okay, I'm writing the half reactions. So in here, I'm just gonna do like this, write it here. So I'm looking at zinc went from 0 and it went to zinc plus 2 charge. So solid state aqueous solution. As you guys can see, it went from 0 to plus 2, right? So oxidation state number increased mathematically. So that's why this is oxidation. Okay. And then if I want to balance this, I'm just going to do a charge balance. We have done it many times. So this is 0 in here, so I write 0 on this side, and then I got plus 2 in here. I need to make both sides equal, okay? So I will add negative 2, and it will make both sides equal now. That 2 is adding 2 electrons, because each electron is negative 1, okay? Now we go into reduction. Let's see which one happened, reduction. Of course, the other one is left is the copper. So copper went from plus 2 to 0. So copper plus 2 aqueous solution on the left side goes to copper 0 solid state, okay? So now let's do charge balance. I have in here plus 2, and then on the right side I have 0. In order to make both sides equal, I will add negative 2 in here. That will make both sides equal, which means that addition of 2 electrons. Now I have both half reaction done for oxidation and reduction, okay? Now using this, let's draw our voltaic cell diagram, because this is spontaneous reaction, right? Because zinc is located higher than copper, this reaction is spontaneous. And that's why we're gonna use voltaic cell to make this, to draw the diagram. Voltaic cell diagram. Now let's remember what we had in the lab. So I had a solution of two solutions. I had copper nitrate solution, okay, which was a blue color, blue solution. And then I had colorless zinc nitrate solution, okay, zinc nitrate solution. And inside this we have zinc plus 2, okay, and then nitrate negative, millions of them. And then on here I have copper plus 2 ions and NO3 minus. This is why we call them aqueous solution. Aqueous solution. Sorry for my handwriting. This is E. Aqueous solution. And then I grab a metal zinc and I dip it inside the solution. And then I grab a copper metal and I dip it inside the copper solution. So please place metals accordingly. I place zinc into zinc solution, copper into copper solution, okay? Now, look at this one. I connect them through the wire, and then I will put a light bulb that will turn the lights on because this reaction is spontaneous. Okay, so look what happens. Look at my half reaction of oxidation. Zinc goes from solid state into aqueous state, okay? So now I'm gonna I know that some of the zinc is gonna dissolve into the water. I will have lots of zinc plus 2 in here. So it's gonna keeps eroding. And then zinc is giving me zinc aqueous solution and electron as a product. So zinc is going into the solution and electrons are going up through the metal, okay? Electron are going up through the metal. So electron in here and here, it passes through the wire, it turns on the light, and it comes to this solution, okay? And then over here, you see the reduction reaction, right? My reduction reaction, where copper aqueous solution grabs 2 electrons and makes solid copper. So the copper in here, the ones I had dissolved inside the copper solution, is coming and binding to the surface of copper. Now it's like there's a lot of copper left on it. Okay, like this metal gets heavier. And then copper is binding with this electron in here, as you guys can see in the reaction, making solid copper. The solid copper is the one that sticks to the metal, okay? So as a product, now I have lots of zinc plus 2 charges in here, and then all of this copper is gone. It's coming and sticking to the metal. Now I got left with lots of nitrate minus ion. So this solution becomes negatively charged. This solution becomes positively charged. Okay, so now I need to balance this, so I'm going to add a salt bridge, because otherwise this electron is not going to be able to go up, because this positive charge is not going to let the electron go and make the electricity. Okay, this is not going to let it go. So I need to neutralize and balance this solution, so I'm going to add inside a salt bridge. A salt bridge with the cotton endings in here. Okay, and inside the salt bridge I can either use sodium chloride or sodium nitrate. The solution, I just dissolved it inside the water. Now I have sodium plus ion and chlorine minus ion, aqueous, or sodium nitrate inside the water, sodium plus and nitrate minus, aqueous solution. Okay, so in here, because it's positively charged, all the negative nitrate ions are going to go through here and neutralize this solution, and then from here then sodium plus ion will come and pass through here and make this negatively charged solution neutralized. Such a horrible handwriting. and then it will make the process will continue. We will have the continuous electron flow. Okay, this is now we together with you guys we draw the cell voltaic cell diagram. Just started with the metals. Okay, we started just with the metals, and all the way down I have written our overall reaction. So this is my overall reaction. These are my half reactions. Okay, and then I also draw a voltaic cell diagram with you. And then over here we know that zinc because this reaction happened, zinc kicked out copper, like zinc oxidized and copper reduced. We know that zinc is higher than copper in activity series. If let's say you're not given activity series table, we can get it from this reaction. Okay, so that's everything, guys. I think it should wrap up really nice for your midterm prep. So I'm gonna upload the original file and my handwritten file, and I would highly recommend you to actually write down as you go in your preparation, and it will help you out tremendously. Okay, take care, guys. Good luck in the exam.